Hi, I'm Bob Tabor. In this module, we're going to give the same treatment to Azure Storage Queues that we did to tables just a little bit ago. And so we're going to start by talking about the things we already know about storage queues. We've talked about them quite a bit in this course. We've used them in a previous course, so you should have some familiarity with what they are. But let's dive in a little bit deeper and come to understand a little bit more about what we can do with them and where they fit into an architecture. So messages are inserted into a queue by some application or process, and they're kept in that queue, in that temporary storage tank, until, in the order in which they were put there, until they're delivered or retrieved or dequeued off of the queue by another process. And so, as we'll learn, this allows you to decouple the parts of your application that are writing and that are reading, or rather that are accepting user input and then processing user input. We'll talk about why that's important in just a moment. But queues have been around for a very long time. This is nothing new to the software development world. It's a simple first in, first out queue in the cloud. So that's what makes it significant as far as Azure is concerned. Now, each message can only be 64K in size maximum, but that should be plenty for the kinds of messages that you'll probably find yourself sending. However, a single queue can hold up to 200 terabytes of messages. And this enables that highly scalable application architecture that we talked about a moment ago. It allows multiple queue writers to work with multiple queue readers. And so here's the scenario, a very simple one. Suppose you have a very popular website. It experiences, I believe that's the next little point here, an unexpected spike in traffic. You can, in Azure websites, say, I need to scale up and scale out both at the same time so you can handle the load. But your bottleneck may not any longer be serving up web pages. It might be writing to a data store. At which points there could be timeouts, there could be locked records in Azure SQL or SQL Server, whatever the case might be. And so in order to combat that, what you do is you decouple the process of accepting information from an end user through a user interface. You take that information that they have submit. Maybe it's an order for products on your book website, or it might be messages that will go into a forum or something along those lines, where you're going to accept a lot of information from end users. You throw it over a wall, you stick it in a queue, and you forget about it. And you deliver a message back on your web page that says, okay, we accepted your input. We'll let you know when your order is processed or when your forum post has been moderated and is visible on our forums. So it sits there in the queue until one or more back-end processes come and start reading it off. Now, in a low-traffic website, at least to begin with, you may only have one process running every 10 seconds, every minute, whatever the case might be, to grab off a new message, process it by running it against your business rules in your application, perhaps even persist information to a database. Regarding that message, you might send off an email. These are great back-end style processes that can be handled, but you give control back to the user, so they're off and they're happy and they're doing something else now. And then it'll pick off another message, and if there's too many messages that pile up in the queue, you can simply just add more back-end workers. So they can each say, okay, I'll take this stack of 10 messages and work on them, and another instance of that back-end worker will take 10 messages off the queue and work on them, and so on. So this helps you, again, decouple, which allows you to scale up much more quickly and not worry about losing data. So let's talk about messages themselves. We already said that a single message can only be 64K in size. Messages can either be strings or they can be byte arrays. And typically I use strings because I'm using JSON for a serialized object or object graph, but you can also create any proprietary message format. Comma delimited files, tab delimited files, an XML document that represents something. Now, if you're going to serialize objects, like I'll demonstrate in a module or two, or an object graph into a queue, then ideally both the reader and the writer would depend on the same interface in that particular case, so that they both know how to work with that particular object graph. Now, ideally, if you're going to be writing and reading objects or object graphs using JSON or XML or something along those lines, ideally, from an architecture perspective, both the writer and the reader would depend on the same C# interface to make sure that they're both expecting the same properties and so on for a given class that represents an object that you're writing out to a queue message. But at any rate, continuing on, whenever you write a message to the queue, it has an expiration date, which is by default 1 week. And so if a reader does not pick it up, or if readers attempt to continually pick up the message and they can't process it for whatever reason, there's some error with the message, then it will expire and go away. So let's talk about processing queues now. To process a queue or to read a queue, a reader, a backend process, whatever the case might be, will grab usually one or more messages, up to 32 messages. Let's say we grab a stack of 10 messages off the queue in a single request and say, I'm going to process these 10 messages. And at that point, then those messages still sit on the queue, but they're just hidden. They're not removed from the queue just yet. They're not removed from the queue until the reader says, okay, I finished processing that message. Go ahead and delete it off the queue. That's called dequeuing. The other scenario is that that the reader takes 10 messages off. It starts with the first message on the queue, and it takes more than, I believe, 30 seconds or so to process that message, at which point it times out, and that message or those messages will then be unhidden and available for any of the other instances of the reader to pluck them off the queue. So message contents and the timeout can be modified. I don't know how often you'll probably process message contents or change them up. There could be some interim step that you need to take to process a message before it can ultimately be processed and something performed as a result of that. However, you can adjust the timeout. So you might say, hey, I see this message, it came in, I'm going to need more than 30 seconds to process this request. I'm going to update that message to 2 minutes. Give me 2 minutes to work on this message before it times out, and you unlock that message. So you can update message contents or the timeouts on the queue while you're processing them. And then finally, messages can be peeked at, which means that I just want to take a look at what's on the queue next. I don't want to actually read it off. I'm not going to dequeue it. Don't hide it or anything like that. Just let me take a peek at what's in the queue next. And then also you can peek at the entire size of the queue and ask how many messages approximately are there on the queue right now. 1,000, 10,000. That might adjust some automatic scaling feature in your software that says, well, then if there's 10,000, I'm going to need to spin up some help to process all these new incoming requests. And so going back to what we talked about earlier with regards to architecture and why you'd want to use queues inside of your application architecture, is that it really reduces the possibility that data is lost due to timeouts to the data store or some other long-running process. So again, that scenario where you're accepting data from end users and there's a lot of processing that has to go on as a result of that transaction. A reader can read it off, a writer can write it and then forget about it, give control back to the user and give them a friendly web page that says, okay, we're processing your request right now, hang in there, we'll get back to you and let you know when we're finished processing. And a lot of like Amazon, for example, I know that they do something similar to this. They'll take your order no matter what, and if they have a problem delivering, they'll write you an email afterwards and say, hey, this thing that you ordered, as it turns out, we don't have any in stock, or it's going to take longer to get it to you. But they don't tell you that at the time of order. They tell you that later on after they've had a chance to actually reserve it in inventory and things of that nature. And then obviously the back ends can just at their leisure pull these messages off the queue and process them. And the beauty here is that you're not going to lose any information. Imagine the scenario where you're trying to, when the user says, yes, check out my shopping cart, I have 100 items in my cart. And so it pushes that order through and it tries to write into the database. You're experiencing a heavy load because it's a holiday season, and it sits there waiting for a connection to the database. and it finally gets a connection to the database and runs a bunch of stuff, but it runs into an error. It can't insert a particular record, and so that insert exception bubbles up, and it comes out to the user interface and says there was an error processing your order. Well, that wouldn't be a very good way to practice business. You're going to lose some orders that way. So this way you can accept all information that comes in and then figure out how to deal with it later on, and never let the end user see you sweat, so to speak. So yeah, I think we talked about all that. The reader will get to it eventually, or to handle more load, just add more instances of the reader temporarily. And this also, queues are awesome because they allow you to send messages between two systems that were never intended to talk to each other. As long as they can read and write to a queue, you can communicate between any two systems, or you can bolt some functionality on the side that enables that. And finally, just like we saw in the how to work with Azure Storage Tables document on the Azure website, there is an equally good article on how do I work with Azure Storage Queues on that same Azure website. And here's the shortcut to get to that page. We're going to look at that page in detail in the very next module. We'll go through the basic common scenarios where you would write to a queue, read from a queue, dequeue it, peek it, so forth. And we'll do that in the very next module. Okay, so this was just intended to be a very high level, quick overview of what queues can do for you and how they work. And after I show you how easy it is to work with them in the next module, you'll pretty much have 99% of what you need to know about queues under your belt at that point. So let's check it out in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor. In this module, we're going to demonstrate how to use queues. We're going to use the great tutorial that's available from Azure's own documentation, that link that I showed you in the previous module that you see right here on screen. And what this will do is not only help us learn the concepts of queues like we talked about in the previous lesson, but then also many how do I style topics, a lot of source code that we'll actually borrow from to either build our own example or move on from there. And really the intent of this module is just to show you where to look for help. You never really memorize these APIs. You should have a general working knowledge, a mental model of how these things work. And then when you need to actually use one, you go to a page like this and you remind yourself like, oh yeah, that's right, I need to use that class, or I need to use that method to do this, you know. And that's just how software developers work. They don't memorize all this stuff. Okay, so at any rate, I would point you to this. As a result of this, I created a simple two-part application. Two Visual Studio projects, one called Queue Message Reader and the other one called Queue Message Creator. So the creator will write a message onto the queue, the reader will read it off. And you've seen these already when we worked with the storage emulator. And so I've cranked the storage emulator back up and it's working right now. So to use these examples that you'll find you can download wherever you're currently watching this video or wherever you currently or originally downloaded it from, you'll need to start up the storage emulator, or you can change the connection string that we're pointing to here in the app.config. They need to both point to the same place, obviously, right? So we'll go ahead and run the creator. And let me pull the result here over. And what message would you like to add? Hello world. And that should be successfully written to the queue. Awesome. And then in the reader, we're going to run. And I've got a little menuing system here. And the first thing that we can do is delay the message and requeue it. We can then come back in. And it looks like it has been requeued and it's not quite available just yet. Let's go ahead, and now it's become available, so we see the menu. So there's a little lag there in the time that it takes to requeue the message. Now we can modify it and then requeue it. And we'll take a look at the code of what that actually did here in just a moment. And then finally we can process it and delete it. So let's go ahead and process it, and the updated contents hello world. So I appended the word updated contents to whatever the previous contents were, and then displayed that on the screen. So you can see that the real magic here is not in the creator. It's pretty easy to just go through the process of connecting to a storage account, creating a queue client, then creating a queue. If it doesn't already exist, then create it. If it does exist, just get a reference to it, and then you start to work with it in an interesting sort of way. Here, this user message is just a string that we're gathering from the user using a console read line, and then we're just going to call add message and stick the message on the queue, and it's as easy as that. So I'm going to shut this part down. The more interesting part of this example is what we do to actually write the message. Now, first of all, I'm going to make sure that there is a message in the queue before I display that little menu. So if you recall, the very first thing that I did was I selected number 3, delay the message and requeue it. I delayed it, so the next time I ran the application, it didn't show it. It just gave me that there was that it was finished, that there was nothing to actually process. And then after a few more seconds, the message was no longer delayed. It was available again, and we were able to read it off. The second time I went through it, I modified it and then requeued it, and then the final time I processed it and deleted it. But I had to make sure that there was a message to process before I would display this menu. So you can see here how I went about peeking at the message just to see if it's available, and if it's not available, then I'm going to bail out of this while loop. All right, so I'm going to process whatever the user selects, 1, 2, or 3. In the case of number 3, what I want to do is I'm going to get the message and then delay it by adding 10 seconds to its invisibility in the queue, and then we're basically just going to ignore it from that point on. When I select that I want to modify and requeue it, here I'm grabbing the message, again calling that get queue method just like I did here, passing in nothing this time. Then I'm going to call set message content, appending the original content of the message with this updated content string, and then calling update message, passing in the message, telling it that it should be made available immediately as opposed to from 10 seconds from now, and then also giving it a bitwise value that says I want to update not only the content but also the visibility of this message. And then finally, whenever we go to retrieve the message, again I'm calling get message, I retrieve the message. Now I can delete the message because let's just suppose that I processed it, and then I'm able to still work with that retrieved message and display it as a string. Now I can go through the process of determining what its type is and then displaying it as that type, like for a date, for example. I just didn't show that in this example. Now, everything that I did in this example, I pulled directly from this web page that I pointed you to here just at the very outset. So I would recommend that you go through this and you look at how I was able to pull just all this code off and then use it in a simple scenario. Let's talk about one other thing here. I'm going to open up another instance of Visual Studio, and we're going to go to the quick starts that are installed with the Azure SDK. So we're going to go to File, New Project. We're going to go to Azure Storage Queues and click OK. And there's something interesting in this tutorial that you don't see in the one on Azure's own website, and that is that it actually works with async versions of all of those method calls. So obviously the first thing we're going to need to do is to get some of these references fixed up here. You can see we're missing a bunch of references. So I'm going to right click and select Manage NuGet Packages. At the very top you can see that NuGet packages are missing from this solution. Click Restore from Online Packages. We've done this before with when we use the Quick Start with tables. And let's update everything to the most recent version. Say accept. All right, it looks like everything is up to date now. So I should be able to right click and select build, and we should get that it succeeded in a build, and it did. Okay, great. So that's how you would set up this example. Also, don't forget you're going to want to adjust the app config, change the storage connection string if you don't already have If you don't already have the storage emulator running, you should, or you can just connect it up to your own Azure account online. But again, one of the features of these quick starts is the amount of comments that they provide, and also articles that point you to interesting things. However, here you can see how to do basic queue operations, async, update in queued messages, so you can, like we did previously, update them, process a batch of messages, you can even delete. And so you'll just want to walk through and look at these. Again, the benefit here is that they work in an async fashion so that you can run other operations while you're waiting for things to happen on the queue. And so I would definitely encourage you to take a look at these. It's a pretty useful example. All right, that's all I really wanted to show you. That's how you use queues. It's as simple as that. There's really no advanced cases that really require any additional explanation. Thank you.